Welcome back, guys. We are ready for another video today, this time on operations with functions. Okay, so this very top section is nice and easy. We don't have a ton to write about. It's really just notation, okay? If we are going to add two functions together, a lot of the times in the books or on tests or questions that you might see, you'll probably see it written f plus g of x, okay? So just remember, this does not, right, these two parentheses, they don't mean, or it doesn't mean multiply, okay? This is just a fancy way of saying we're adding the f function and the g function together, okay? So, same thing with subtraction, f of x minus g of x, well, we write it as f minus g of x, all right? We keep moving on. If we're going to multiply two functions together, we write it as fg of x. And lastly, if we have division of two functions, we write it as f divided by g, or f over g of x. Alright, so I really don't even need to write these ofs, but whatever, we can have them. So, what have we been concentrating on the last couple of days? Domain. What is important here? Well, do you think we care about the restrictions of f, the restrictions of g? It's actually both, okay? We need to worry about, must find restrictions from both f of x and g of x. Hold on, guys, this paper's not doing so well. I'm going to move this out of the way. Okay, so yes, we must find the restrictions from both f of x and g of x. Now there's one other thing that hopefully you guys might actually just be able to notice on your own. What's going on with division? We have this g of x in the denominator, and what do we know about denominators when we're looking for domains? We know that it cannot equal 0. So that's kind of a special case that I want you guys to keep in mind. All right? Okay. Let's get into some problems to see what is going on with this. So we move down. We see that we are taking the f function, the g function, we're adding them together. So we're going to just write that to start. All right, I have f of x, or 1 over x plus 2, and I'm adding x over x minus 1, right? I took f of x and I took g of x and I added them together. Now, we need to clean this up, right? We are not done with this. If we are adding fractions together, what must be true? If you said common denominator, then you are absolutely correct. We need to make sure we get these to have a common denominator. Easiest way to do that, if this one has an x plus 2, this one only has an x minus 1, well, we want to basically multiply by an x minus 1 on the left side and an x plus 2 on the right side. And then what's really important though, can you just multiply by x minus 1 on the bottom, or on the right side x plus 2 on the bottom? Absolutely not. That would change the value. Okay, when we multiply, the only way to multiply without changing the value is to multiply the top and bottom by the absolute same thing, because what is x minus 1 over x minus 1? It's just 1. Alright, so that does not change the value. Alright, so now that we have this work set up, we need to clean this up. What's really nice, and what we're going to do, we are just going to make one division bar, and the denominator will be the common denominator. And now we have to do some distributing, okay? So x minus 1 times 1, that's nice and easy. And then we have to distribute x to both of these pieces. So I'm going to add x squared, and I'm going to add 2x. Alright, so we're almost done here. One more time. X minus 1, x plus 2, and then what do we have here? X squared, because we want to go in standard form. So x squared, and then we have a positive x, positive 2x, so positive 3x, and then lastly a negative 1. Alright, so now we know that this is f plus g of x, which is nice. We wanted that for sure. We have to get the domain though, okay? And we have to remember the domain, if we go back up, the domain and the restrictions really come from both of our functions. So let's take a look now. You guys hopefully are getting pretty good at this by now, and you might not even have to really set up huge long problems. We know that because there's an x plus 2 in the denominator, well then it cannot equal 0, right? Which means what? That means that we cannot, or x cannot equal negative 2. And how about over here? Cannot equal 0. So here we have x cannot equal positive 1. Alright? So we come over here. If it can't equal negative 2 and it can't equal positive 1, that means it can equal absolutely everything else. So we go all real numbers except x cannot equal negative 2, 1. Now what's really nice, and hopefully you guys are noticing, we can get that information from where? From here as well, okay? So what I want you guys to just get in the habit of doing, look at your restrictions everywhere. You go from the beginning and all the way through your work, because any restriction that you see anywhere will be a restriction at the end. Alright? Cool. So let's take a look at the next one. This one shouldn't be too bad. We can actually use quite a bit of our work from the problem above. So what do we have? X over x minus 1. Oh, sorry about that, guys. Please, that's a minus. I'm very sorry about that. Okay? Alright, we are going to do the exact same thing to get our common denominator. So here we had x minus 1, x minus 1. Here we had x plus 2, x plus 2. Alright, the only real difference at this point, hopefully we see, is, let me get there. Okay, when I go to distribute, this is going to be the same, x minus 1. We have to be real careful though. This is not positive x times x plus 2. This is negative x. So we need to distribute negative x times x, which is negative x squared, and negative x times positive 2 is negative 2x. Alright, hopefully we see that. When we go to clean this up, we still have our x minus 1, x plus 2, and now we should have negative x squared, negative x, negative 1. At this point, I'm okay with this. Yes, you could factor out a negative 1 from everything in the top. I'm not worried about that at this moment in time. When we look through everything, okay, we already knew our restrictions from f and g, from those individual functions, I should say. If we look through, they're all the same. There's no new restrictions. So we go all real numbers, and once again, x cannot equal negative 2 and 1. Alright, oh, and last thing, my bad. Make sure we write our function notation. Okay? Cool. Let's see what is going on with this next one. Okay, so we have f times g. Alright, this is the same as fg of x. So we're going to take our functions, f, and we're going to multiply now. Okay? Now this is way nicer. We know that when we multiply fractions, we don't need common denominators, right? We just multiply across, top with top, bottom with bottom. So this is really nice, okay? 1 times x is x, and then these two multiplied together. Don't even worry about multiplying this out, because I need to see the restrictions anyways. So we leave it just like this. Alright? Again, we look for restrictions. We knew what? Same from f and g, and then nothing changed. There's nothing new. So once again, all real numbers except x cannot equal negative 2 or 1. Alright? Now, suggestion time. Please note, when we are working with something like d, when we're dividing, we have fractions in our original functions, and then we're going to divide it. So really, the problem is we don't want to make a giant complex fraction, okay? So we're going to use something that probably looks a little closer to what you might have done in grade school, and we are literally going to write the f function, and we're going to use that old division sign that we probably haven't used in a while to write our operations with the function, okay? Why do we do this? Well, hopefully you guys learned something about this in grade school, maybe something like keep, change, flip, that when you divide by a fraction, you can always do what instead? You can keep the first fraction the same. You can change the sign, so I'm changing from division to multiplication. And then what am I going to do? Well, I'm going to flip, or get the reciprocal of the second function, or second fraction, okay? Why do we do this? Well, now it's very much the same as what we did above. I'm going to multiply across, so my top is just x minus 1. When I multiply these, I'm going to have x times x plus 2. Order doesn't necessarily matter. I just tend to put monomials in front. So if you wrote it x plus 2 times x, that's fine, not a big deal. Alright, so let's think about this. We know from what? We know from the very original, okay, from the very, very original function, g function, what? That x cannot be positive 1. Alright, so that still holds true. Same thing with this negative 2. What happened here, though? What happened? We have a new factor in the denominator that we have to worry about, right? We now also know that x cannot equal 0. So we have to use every single restriction that we've had from f, from g, and from our operation as restrictions, which means x cannot be negative 2. It still can't be 1 from the original. Sorry, I'm pointing at stuff you can't even see from the original g function. And now we can also add that it cannot be 0 from this operation. Okay, last thing, my bad, I forgot this once again, f over g of x. Okay? Alright, let's work on some other ones, alright? So as we move on to the next page, and we come back up to the top, what do we have going on here? Okay, we have some subtraction. So, let me make sure. Alright, we are good. Sorry about that, guys. Trying to adjust my paper so I can write a little easier. Okay, so we have f minus g of x. So what are we going to do? Well, I am going to take my f function, and I am going to subtract the g function. Now, you have options here. You can choose. If you understand that it's subtraction, which means you're just going to make everything negative, that's fine. I personally am going to add one extra step, and I'm going to say minus the entire function, okay? Because now what am I going to do on my next step? Well, I'm going to distribute this negative. So this turns into 2x cubed plus 3 minus 4x squared minus 1. Okay? When we keep going, when we write in order or kind of clean everything up, we get 2x cubed minus 4x squared, let's see, and plus 2. Okay? So this is our function. This is f minus g of x. Hopefully we're getting pretty good at that. Time to work on the domain, okay? The domain. What are you thinking here? Hopefully you guys are, again, getting good at this and you realize there is no denominator. There is no radical. There's nothing to restrict the domain. So, of course, we say domain is all real numbers. All right? Now, the very last part, or part B, we know that because the domain is all real numbers, that we are going to be able to get a value when we plug in 2. So we're really just going to do it, okay? I'm going to say f minus g of 2 equals, and I'm just going to plug 2 into my function, okay? So 2, and then I think it was 2 cubed, yep, minus 4 times 2 squared plus 2, okay? Let me hold that away for a second. I know I'm lefty, so it's hard to see everything. All right, so when we clean this up, we get, what is this, 2 times 8 minus 4 times 4 plus 2, so 16 minus 16 plus 2. Okay, we know that f minus g of 2 is equal to 2, and we're done. Okay, let's take a look at the next one. F minus g again. Okay, more subtraction. We have more subtraction. What are we going to do? We're literally just going to write the f function minus the g function. So, square root of x minus 2 minus 2x plus 7. When I go to clean this up, x minus 2 minus 2x minus 7. All right? Be very careful here, guys. We hopefully understand anything, x is, like if there's an x under a radical and then an x not under the radical, we can't combine any of this together. So it's very important that you're careful how far your radical bar goes and everything, because literally we are done with this. Alright, f minus g of x. Alright, yeah, that's our function. There's nothing else to do. Now, domain-wise, we know what? We know that because there's a radical, x minus 2 must be greater than or equal to 0, so x must be greater than or equal to 2. So, domain, x must be greater than or equal to 2. Once again, when we move on to something like letter B, we see that we're trying to find, or we're trying to evaluate the function at 5 that is in the domain. We are good to go, so we plug in f minus g of 5, okay, equals. Awesome. Keep going. So this is square root 3, negative 10, negative 7, so minus 17. Guys, I would leave it just like that. I would not put it into the calculator and get a sloppy decimal. I would just leave it right like that. Okay? So, there you go. Not too bad, hopefully. Hopefully. When we move on to this next one, we're moving on. We have some multiplication going on here. So, let's check it out. We are going to take our f function. We are going to multiply it by our g function. And remember, there's nothing much else to do here, okay? We're just going to rewrite this as one fraction. Alright, so I'm going to make a giant fraction bar. I'm going to say the top has to multiply by the tops have to multiply by each other. So 2x plus 1, x minus 3, and then x plus 7, 2x plus 7. Alright, so you have options here, and again, you have the only reason, or the reason that I'm saying you have options here, these bottoms, these denominators, they don't change. So you can get the restrictions from either place because they kind of stay the same throughout. So x plus 7 cannot equal 0, so x cannot equal negative 7, and 2x plus 7 cannot equal 0, so 2x cannot equal negative 7, x cannot equal negative 7 halves. So, domain, if these are the two values that x cannot equal, we say that it can be all other real numbers except x cannot equal negative 7 halves and negative 7. Alright? And this was fg of x. Alright. So, once again, we take a look. Is 3 within the domain? It sure is, okay? So we could just plug it in. Fg of 3 equals, and I just plug 3 in everywhere, okay? So actually, you know what we'll do? How about this? I'm going to just kind of leave places, and we're just going to plug 3 in over here kind of in our head, okay? So if I plug 3 in, 2 times 3 is 6, 6 plus 1, okay, so this would be a 7. 3 minus 3 is 0. 3 plus 7, 10. 2 times 3 is 6. 6 plus 7, 13. Okay? You guys can do what you want to clean this up. Hopefully you guys notice that this would be 0 over 130, and then of course we know that 0 divided by anything is just 0. Alright? Alright, almost done. Last couple of examples here that have to do with division. Alright, so we have some division. Let's take a look at this. Okay, so we are going to do f over g. F over g. So I would strongly encourage you, again, because we have some fractions, to write it that old school way, or not make a complex fraction. F is fine, right? F we can just say is x minus 2. But what are we going to do here? I'm going to say divided by 7 over x, because what can I now do? I can flip it. I can keep, I can change, and I can flip. Alright? Now if it helps, go ahead and put that over 1, because we know then that this will be square root of x minus 2, all over 7. And that is f over g of x. Now restrictions. We have a couple of restrictions. Hopefully we agree. We have restrictions here, right, because we have a radical, and we have restrictions here because we have a denominator. So let's go through both of those. So x minus 2 must be greater than or equal to 0 because of the radical, so x has to be greater than or equal to 2. Also, nice and easy, x cannot equal 0. Alright? Now, just to kind of review from the other day, let's make a number line here. We put 2 on it, we can put 0 on it. We know that we can have a 2 filled in, and then we'd go everywhere to the right because it's x is greater than 2. We also know we would have an open circle at 0. So we have to be very careful here because we do not want to be redundant. What do we say? Well, x definitely has to be greater than or equal to 2. Do I need to say that x cannot equal 0? Hopefully you just said no. You do not need that because 0 is already not within the domain of x is greater than or equal to 2. Alright, so you're done right there. Which is a perfect example now that when we look at b, we don't even have to do any work, right? If we're trying to get, or if we're trying to evaluate this function at 0, but we know that the domain is x must be greater than or equal to 2, well, 0 is not in there. So, no solution. Alright? Awesome. Alright, last one. Let's try and get through this one, and then we will be on our way. So, we have f over g. This is one where I probably would use a division bar, right? I don't have any fractions in my original functions, so when I put them over each other, I'll just have a normal looking fraction, okay? So square root of x minus 1 over square root of 4 minus x. Alright? That's it. We're done. Oh, I don't even have to write this, okay? That's my only step. I don't have to do any other simplifying. When we go for the domain, again, we have what? Several restrictions. Okay, we have several restrictions. We know what? We know that f of x is square root of x minus 1. So this x minus 1 must be greater than or equal to 0. Okay? So that would be x is greater than or equal to 1, which is good. Now, we have to be careful. And this is one where you can kind of kill two birds with one stone. If we tried to get the restriction from g of x, this would be just a radical, and we could say that it's greater than or equal to 0. However, because when we did this problem, or sorry, not problem, when we combined or completed the operation, it is now in the denominator, I can further say that it has to be greater than 0, because it also cannot be 0. Okay? So that's one, just be careful. Don't do extra work if you don't have to. So let's see what is going to happen here. Well, I'm going to add x, so 4 must be greater than x, or I'm going to reverse this just to make it look a little nicer. X has to be less than 4. Good, perfect. Numberline this, numberline this. We have some boundaries at 1. I have another boundary at 4. I know that it can equal 1, so I put a closed circle. I know that it cannot be 4, so I put an open circle. Now let's think. Well, we have to be greater than 1, so we start shading. And what else do we know? We have to be less than 4, so that we can only go right there. So last thing we have to do, we have to write this as a domain and as a sandwich inequality. All right, so remember what we say. We go in order from smallest number to biggest, so 1 and 4. And remember that x is going to be sandwiched between them. Just be careful of your signs now. I'm going to say less than or equal to, okay, 1 is less than or equal to x, and then x has to be less than 4. And that would be our domain. And lastly, let's evaluate this function at 0. Okay, so go ahead, plug in 0, see what happens. Hopefully you guys didn't even start working, okay? How do we know that we don't even have to do anything here? 0 is not in my domain. 0 would be over here. I can't do it. We're done. All right, so that was a introduction/reintroduction to operations with functions, and then we really want to make sure that we focus on the domain aspect of it after you complete the operation. All right, hopefully that made sense to you guys. If it didn't, of course, always email me, ask me questions in class. I want to make sure that you guys are understanding this. All right, have a good day.